Use the figure shown on the screen to answer the given questions. Join points C and D to have the labeled lines CD. From quadrilateral EFCD, the sum of angle EFC and angle EDC equals 180 degrees, so that angle EDC equals 180 degrees minus 60 degrees, which is equals to 120 degrees. Thus, solving for angle CDB, we have it to be equals to 60 degrees. This implies that triangle CDB is an equilateral triangle. All side lengths of this triangle equals to 3 centimeters. From triangle EFB, let its side length be x. This implies that line labeled ED equals to x minus 3. Consider triangle EFD and using cosine rule. Substitute values, simplify, and we have a quadratic equation in x which we can solve for. Rearrange terms of the equation in one side and use factorization method since it is factorizable to have that either x equals to -12 or that x equals to 15. Since measurement of length cannot have a negative value, thus x is not equals to -12. Therefore, x equals to 15 centimeters. Consider triangle CDF and solve for line label CF, which is equals to 12 centimeters. Angle DCF equals to 180 degrees minus 60 degrees equals to 120 degrees. Area of triangle CDF given as A equals to the product of 0.5, line labeled CF, line labeled CD, and sine angle of C. Substitute values and we have the area A equals to the product of 9 and the square root of 3 all in square centimeters. We call it equation 1. Consider triangle EDF. Let its area be y. After substituting values, area y equals to the product of 45 and the square root of 3 all in square centimeters. We call it equation 2. Therefore, area of quadrilateral EFCD Q equals the product of 54 and the square root of 3 all in square centimeters. For solution 2, label center O and join line OF and line OD. These lines equal to the radius r of the circle. Angle DOF equals to 120 degrees. Using cosine rule and substituting terms and simplifying, we have equation in R as shown on the screen. Simplify further and we have that the square of R equals to 63, but area of a circle is given as the product of pi and the square of R. Let A be the required area of the circle. Therefore, the area A in terms of pi equals the product of 63 and pi all in square centimeters.